All right. Hello, everyone. My name is David Kapp. I am a cat video aficionado who moonlights as a software developer. I work for Koshx Labs, which is a company based out of Charlottesville, Virginia. I used to work in the Boulder, Colorado office of the company. I moved to Austin about a year ago, and so I'm the only person from the company currently in Austin. Having been in Austin for about 1 year, I've been here longer than 2/3 of the population, which I'm very happy about. I really enjoy the tech scene here, so I'm happy to be a part of it. And I gave a talk on an introduction to asynchronous workers at RailsConf this year. And they were kind enough to invite me to give a follow-up talk on some patterns of asynchronous worker use and a little bit of details on some ways to deal with the concurrency problems that can come up. And so that is what I'm going to speak about today. I have a reasonably large amount of material, and I will try and watch the time as closely as I can to allow for some questions. But concurrent processing and parallel processing are large fields, and it's going to be difficult for me to cover a whole lot of material in half an hour, but I hope to cover as much as I possibly can. So, asynchronous workers to the rescue, parallelism patterns. So, I have some good news in case you haven't heard it. You might have heard that Ruby 2.0 has come out, which is great. And I'm sure that many of you are extremely happy about this. I know I was very happy because there are some great improvements in Ruby 2. However, there are some of you whose dreams were not fulfilled by Ruby 2.0 because there is still a global interpreter lock. And those people might have been a little bit disappointed in the release. But it doesn't sound like the GIL is going to be going away anytime soon. It's something that we're going to have to deal with in MRI. If you're on JRuby or the latest builds of Rubinius, this is a different case, but in MRI it's still around. And I would like to encourage everyone to calm down. You can see the mass panic that ensued in the room when I mentioned that fact. And the truth is there are still options for parallelism in Ruby even when you're on MRI. And it's also true that some traditional parallel programming techniques don't really work well with Ruby. You may or may not be familiar with the way the MRI works or what the global interpreter lock is. The GIL, global interpreter lock, is something that prevents more than one thread within a single MRI process from running code at the same time. That is, Ruby has true native threads now, but it cannot actually execute more than one of them at once. Python has the same setup. Many languages have it. It's not something unique to Ruby. And when you're doing an HTTP request response-oriented system, which I'm guessing many of you are, Rails is the thing that has brought commercial fame and fortune to Ruby. When you're dealing with that, a lot of what you're doing probably does have some form of parallelism in the fact that you're running multiple processes on your servers. I don't know too many people who are in production only running a single instance of Passenger or Puma or Unicorn or Rainbows or what have you. So the basic idea of parallel processing, if you're not familiar with it, is that you have a big problem. A problem that's so big you don't want to do it all at once. So you take that problem and you break it into small pieces. You work on each of those pieces separately, and then after you've taken those individual pieces, you put them back together and you either construct or reconstruct that solution depending on your point of view. It's really like solving a puzzle. You have all these different pieces that represent an aggregate solution, and you have to get it back into one. There's really nothing that's Ruby specific about that idea. Parallel processing has been around much longer than the Ruby language itself. And there's more than one way to approach parallelism in pretty much every language. Some languages have language-level features to support it. Other languages do not. And here, the approach that we're going to be discussing, asynchronous workers, is an approach that really does work very nicely with Ruby, multiple flavors of Ruby. So asynchronous workers have many ways that they can be used. They're more of a tool that can be applied in different ways to different situations. I'd like to talk about three main techniques or patterns of using them. And those will be isolating slow activities, pipelined processing, and periodic maintenance tasks. And I would also like to mention an aside, if you're not familiar with asynchronous workers or why you might care about them, there's a few reasons why they're a good approach to this sort of problem with Ruby. And that is they're very flexible. There's a lot of different ways they can be used, and they offer you a lot of choices on the way you want to apply their processing techniques to a given problem. There are several Ruby libraries, which I'll mention by name in just a moment, that are very mature. And they have got a lot of battle testing And even the most recent of them, Sidekick, is quite stable. So you have a choice of many different things that you could work with. They do not rely on threads or fibers or the global interpreter lock being there or not being there. So that is, they work with MRI, they work with JRuby, they work with Rubinius, and there are a few other Ruby libraries out there, but odds are you're not actually using them in production. They are relatively easy to work with, and the reason I like them so much is because you can actually use them to avoid a lot of the traditional concurrency problems. Concurrency is hard, and when I can get the benefits of parallel processing and plug my ears and say, la, 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 none of these other problems exist, it makes my life easier. And you can think of them as a primitive to compose complex solutions. And that goes in hand with the flexible part. You can use them in many ways. Now, that might be a bit of a controversial statement. You have parallel processing in which you don't have to deal with concurrency issues. Doesn't that sound implausibly good? And the truth is, yes, it does. You can't rely on them to magically solve your problems. However, you can use them in a manner that will allow you to ignore many of the traditional problems. And with all these libraries, you run into different situations and different choices, but the patterns of use apply to all of them. So up front, before we start talking about the different patterns, I'd like to just mention 2 best practices that will save you a lot of sanity and a lot of swearing. And these are, in my opinion, the 2 best things you can do with asynchronous workers to avoid concurrency problems. Number 1 is a concept called shared nothing, and I believe I stole this terminology from Clojure, in which they like to use the term. The idea of shared nothing is that you do not actually have anything in terms of state or in terms of objects that are shared across things. So even if you are working with the same domain models or the same database backend, you do not share the specific things you're working on across asynchronous workers, across threads, anything like that.
Teradata.
Yes. The less that you can share between these things, the better off you will be. And that is because the less you are sharing, the less you have to worry about these concurrency problems. And next is having your jobs be idempotent. I've also heard this pronounced idempotent. If anyone can provide me with strong evidence one of these pronunciations is correct, that would be great. I can't actually determine that. And I would like to give an addendum on that. That is, there are things that you can't do this to. If you're not familiar with the idea of being idempotent, that is that you have something that even if it is repeated, you will not change your state. The most common example of this is using an ATM. You want something to be an idempotent transaction there because if you have to repeat something, that is the initial application fails and it has to be played back from a log, the person's account does not end up with a different amount of money. This doesn't really apply to all situations, and there are cases where you can't do that. A simple example is when you're dealing with things based on time. If you have a function such as time.now, and you call that in multiple places, it's not going to return the same thing unless you're using timecop in production, in which case you've also probably got some other problems. So some things simply can't be made idempotent. And if you're working in a language like Haskell, you would have to use monads to work around that issue. Thankfully, you don't have to do that in Ruby. In Ruby, you just have to keep in mind that you are going to be working with something that's not idempotent. And again, some things may seem idempotent, and it's difficult to come to an actual consensus because it's not necessarily a scientific term when we're dealing with business applications. When you're dealing with mathematics, it is a separate thing. Things can easily be proven to be idempotent or not. However, when you're dealing with an application, it often is difficult to say. So my suggestion for is, even if you can't get true idempotency, aim for understood failure. That is, you know exactly what will happen if something does fail, and minimal impact if repeated. So you want to try and get the benefits of idempotency even if you don't have a true idempotent transaction. There's this concept of referential transparency, which is a great term because it makes you sound really intelligent when you say it. And what it means, it's a term that comes from functional programming. It means the output of a function will always be the same given the same parameters. If you have a function called add2, and it adds 2 to the number you pass in, you can very easily prove that that has referential transparency. Given the same number, it will always return the same value. This is something to strive for because, again, when you're dealing with business applications, it may not actually be possible. And I'm not really a fan of the term business logic or business application. I'm just using it as a general term for something that is going to be doing practical rather than purely mathematical work. You can apply this idea to asynchronous workers. So I would like to call that referentially transparent workers, which might sound like a bit of a mouthful, but what I mean with that is you should aim to have workers that when the job is executed, you know that it's going to produce the same result given the same input. And that will make the behavior of your asynchronous jobs more consistent and more composable and more easily understandable. So yes, let's go back to the whole idea of asynchronous workers. I'd like to define them just a little bit more in case you're not familiar with the term. An asynchronous worker is something that is a separate process from the rest of your application. Since I'm going to be giving some examples using Rails because that composes the majority of the work that a lot of people do, but the same ideas apply to using other servers if you're on Sinatra or one of the others, or if you're doing an application that's not web-based. Regardless, an asynchronous worker is separate from the rest of your application. It is something that reads data from a specified place, and it processes it in some way, and it will periodically pull this data source to see if there's more to do. It may or may not be actually polling. Sometimes it'll get notifications in a different manner, but it is generally polling rather than getting events from the OS. There are three main libraries for asynchronous workers in Ruby. They are Resque, which is the one the examples here are going to be in, Sidekick, which was originally made to be API compatible with Resque, but it uses a different model for managing multiple jobs at the same time, and Delayed Job, which is one that instead of using Redis as the data backend, uses an SQL database. I would encourage you to pick the one that is the best for your project. There's no guaranteed statement that this is the right thing that you should be using and the others are wrong. I wish I could tell you that one is always better than the others, but it's not that simple. One thing that may influence your decision greatly is if you have to have things run on Windows. I believe the only one of these that can run on Windows is Delayed Job. I may be wrong on that, but that may influence your decision. So again, I am going to give examples with Resque, but please do give some thought. Don't simply pick up Resque and say this is the one because I have given the examples using it. You may have heard someone use the term asynchronous worker queue. And that is not necessarily indicative of how they're going to behave. It's simply that on a conceptual level, they operate as though they are reading from a data queue. The backend may or may not actually be a queue. You simply can think of it as a place where the jobs are enqueued to and will be dequeued from when their data is read. And here's a friendly warning, just in case you're thinking about using JRuby for an upcoming project, and you're thinking that you're going to use Sidekick, and you have the JVM, and you can sidestep the global interpreter lock, so you can do all sorts of neat stuff inside your worker processes. I will recommend you read this. There's an article called Ruby Core Classes Aren't Thread Safe. It will save you a lot of frustration, and I will make these slides available so that you can actually click the link instead of just staring at it. It is an excellent article, and I would highly recommend you familiarize yourself with the contents of it if you are using JRuby. So let's go on to the first of the three patterns we're going to discuss, and that is how to banish slow things so they do not bother you anymore, or at least banish them into an asynchronous worker job so that they will not bother your main application. Applications sometimes have to do things that are slow. This is sometimes due to the necessity of the complexity of the calculations you're doing, or it may, in many cases for us, be a slow API call you have to make. If you have an API call that takes 15 seconds, no amount of algorithmic improvements on your side will actually change the fact that the other server is still slow. And I bet if you ask the users of your application if they enjoy clicking on things and having to wait 15 plus seconds for a response, you will overwhelmingly find that they are not interested in that waiting. So even if you try and apply changes to make the rest of the things there faster, you're only incrementally increasing the speed and not really dealing with the true problem. What you need to do is deal with it a different way. That is, HTTP request time is different. Something that is slow for an HTTP request response cycle is different than something that would be slow were you doing some sort of giant batch data processing job on a mainframe. If you have an HTTP request that takes a minute, that's really just as bad as a 15-minute one. Your users aren't going to put up with it, and most browsers aren't going to allow you to actually wait that long. So what you need to do is change the architecture of your application a little bit. You need to take that thing that's really slow and take it out of the request response cycle. The same idea here applies to doing things such as drawing graphics on an event loop. If you do any iOS development, you may be familiar with how you are not supposed to do drawing to the screen on the main event loop, and that is so you're not holding up everything else. That applies to the Rails request response loop, where you don't want to hold up everything because you're taking a long time to process a single HTTP response. So you're probably wondering, or at least I hope you're wondering, how does an asynchronous worker actually help me deal with this slow stuff? What you are doing is a synchronous call to something that is slow. That means you cannot move forward until it is done. What you want is this to be asynchronous. You want it to start. That is, you want the processing to actually begin, but you want to keep going on without it. And by doing so, achieve a form of parallel processing in which your application will still have the other work done, but it is not being held up. So what we want out of asynchronous workers is the ability to asynchronously process slow things, preferably in parallel, with our main program. So we want the slow things to not slow us down, especially the HTTP request handling, which is what most of us are probably doing to bring in money. And I'm willing to bet most of us like money. So, asynchronous workers. To recap what I said, we have our proverbial dump truck and a proverbial slow thing. We're going to load it on there and have it brought elsewhere for processing. I think this picture nicely captures all of these proverbial things at once. Now, I explained it a moment ago, but the general answer is, why do we care about isolating slow things? Because we want our application to feel responsive. Even if the actual processing is still taking a long time, if your application feels responsive, that's generally what the user cares about. So some good things to have your workers do: call external APIs, especially the really slow ones, perform numerical crunching, generate documents your user might want, manipulate images or video, send emails. This is one where, even though generally sending an email is a relatively quick operation, if you're using a third-party service for it, we use SendGrid quite frequently. SendGrid is generally really fast, and if you do this synchronously, it's not a problem. But if they have some sort of server outage and they're down to 5% of their servers for a little while, your entire application could get held up because of it. If you're doing it asynchronously, you don't have to worry about that. And payment processing, which can sometimes be quite slow, and geolocation, which again can also be quite slow depending on what's available to the machine. All of these things are not required immediately upon response. That's what makes them good candidates for being processed in an asynchronous worker. Let's give some code examples so that you can see this in action. A worker class looks something like this. If you look at it, this is a worker for rescue. Depending on which you choose, if you're in delayed job or sidekick, it'll look slightly different, but in general, they look like this. It is a class. In rescue, they have the queue set as a class instance variable, and that does not have to be unique, although it often is. And a method named perform that is a class method. The fact that it is a class method is important, and the fact that it is named perform is important. You pass it some arguments, and it does some stuff. Don't worry too much about the details of what stuff it is, and please don't try and write down the entire code example. Some things to notice from there. Again, the @q in the class, you do need to tell it where to write this stuff. The perform class method receives the arguments that were queued along with it, which means that you do need one class per job type. That's not a big deal. In fact, that's good because it means you have lots of things to handle specific small pieces of work. And a slight aside, you may be wondering where you put them in a Rails project. I usually put them in lib. Some people like to put it in models. Some people put it elsewhere. What's important is not where it is put, but that your team is consistent. And you might have also noticed that I was using Rails inside something that is not a Rails server. That is correct. You can use Rails stuff inside of your asynchronous workers. You do need to configure this, but it's very simple to do so. And you have the option of leaving it out if you want your asynchronous workers to start faster. Although, to be honest, every time I see someone do this in an application, they load it. It is generally worth it because it gives you complete access to your active record models and the rest of your domain things from Rails from within the worker. But you can leave it out if you're sure you don't need it and you want the faster startup time. To load Rails, you simply create a resque.rake over in libtasks, and you make resque setup depend on environment. And that means that you will now have Rails loaded on all of your asynchronous workers. To call the worker, please take a look inside the create method at the line after if at user.save. You call resque.enqueue, the class name, and the arguments. In this case, we're only passing one argument, but you may pass multiple. And notice how down in the else clause, we are enqueuing a different type of asynchronous worker job. It's true we're leaving out a lot of details here. There's not much logging. There's not much formatting done. What I really want to emphasize here is simply the fact that you're calling resque.enqueue. So things to notice, you simply call resque.enqueue class followed by arguments. You'll naturally not type resque if you're using something else. And whatever args you enqueue or serialize as JSON, don't pass arbitrary objects. If you try and pass active record objects as is to the serializer, it will get upset at you. Serialize simple arbitrary values. If you need to access something out of the database, pass the ID. Or pass a JSON hash that represents all the information you need about the object. That would actually be preferable. So, you've done this. Congratulations. Your job will now be processed separate from Rails, or separate from the rest of your application if you're not on Rails. The problem now is, of course, you've just sent back the user something without that data being processed. It's not done yet. So, you need to get that data back. There's two main ways to do this. First is the data is simply on another page. I like to call this the check back later approach. You simply tell the user, if you come here at a later time, we'll have what you're asking for. This is generally more useful for something that's going to take a while to run, and you say, come here to get your financial report. It'll be done in about 10 minutes. Or you can asynchronously load the data via JavaScript. You can set up something that's a little bit fancier than polling, but in most cases, polling works just fine for this purpose. And you'll probably display some sort of indication to the user that it is being loaded. You do need to know where the data is going to be. Determine this ahead of time using your routes. Or you can generate a hash and look that up. That would be, along with the response, you pass along some sort of hash code that you generated, and it knows where to go and find information about whatever object was associated with that hash. Users do get annoyed with pages that are full of too many loading wheels. If they go to a page and there's 10 of the little spinning gray circles, they're not going to be thrilled, especially if they're on a mobile device. On a mobile device, having that much asynchronous loading going on can be really annoying. So use this technique judiciously. Don't ignore it, but overdoing it will generally make the user experience quite poor. And of course, I mentioned that there are concerns that you have to deal with in terms of using your data and encountering synchronicity problems. Be careful with mutable state. The usual thing you will run into is something called a race condition. This is what happens when you have two things modifying the same data at the same time. And if you have your asynchronous workers modifying data in your backend, probably your SQL database, but it could be another form of database, you are going to run into race conditions and strange things are going to happen. So you need to be careful. Be especially wary when you might have the same object or the same data in multiple workers at the same time. If you're using the state in the database that might be read by multiple workers, especially if it might be modified by multiple workers, you probably want to adjust your workflow so that you do not have the possibility of having multiple things doing this at the same time. Eliminating the possibility by rewriting the order in which processing is done is generally going to be a lot easier than trying to set up a lock of some sort. So, as I said, you do need to be careful of these situations. Otherwise, you're going to run into some problems, and you're going to encounter very strange data issues. I'd like to go over the 4 rules of concurrency from the JRuby wiki. I think they're very helpful. Rule number 1 is don't do it. Congratulations, you can now go back and say parallelism does not need to be done. You got your money's worth out of this conference. They're probably not going to take that as an argument, so number 2 is if you must do this, don't share data across threads. For JRuby here, they say threads. You can read that as asynchronous workers. If you must share data across threads or asynchronous workers, don't share mutable data. And if you must share mutable data across asynchronous workers, synchronize access to it. So what should you do? The best choice, as I said, is simply don't do it. As they said, don't do it. But since you might have to, if you do need a specific state at a given point, or you have a mutable object, there are generally 2 ways to deal with it. The first is using a lock. You'll often hear this referred to as a mutex. This is often database level using a database transaction because a mutex lock is generally within one process, and your asynchronous workers are each a separate process. It is possible to have a system-level lock in which you have a single mutex lock that is shared across multiple processes. This is very error-prone. Try to avoid that. As I said, it is very easy to mess up. However, using database transactions is generally very straightforward. You can look up the ways in which Active Record provides access to it, or you can look up the ways in which you can do it manually if you're doing an approach other than using Active Record. The other choice is to make a copy of the state and do the processing on that. If you've heard about the way Clojure handles things, or you've heard the term copy on write, well, copy on write is different, I apologize. The way Clojure often handles mutation is that anything that mutates an object returns a copy that has been changed. It never actually returns the original object. You can do that in Ruby, it just has to be something you are manually making sure you are enforcing. Ruby is not going to enforce it for you. If you make a copy of the state and do the processing on that, you don't have to worry about the data getting modified from underneath you. And if you're using Resque or Sidekick, you have Redis as your data backend. And Redis is a great place to write temporary values. That is, you're going to take your object, the state of it at the time that you need this information processed about it, copy that information out, and then work with the copy for the rest of the flow. In that way, you are not going to be modifying the original data. Just make sure you don't write back to the database. So the process of making a copy of the state and working with that is very similar to sending parameters to a method call. And when you enqueue a worker job, you're going to write the parameters out to something, which is a copy since it's going to Redis, which sounds a lot like pipelining, which is my shameless segue into the second technique, which is pipelining. Pipelining is a general term for doing data manipulation in a specified step-by-step sequence. So, pipelining. Since an asynchronous job doesn't inherently bog anything down in your application, it's tempting to make it do way too much. I encourage you to resist that temptation. This is an example of a very bad way to write something that I have seen many times when working with asynchronous workers, and I am guilty of writing things like this on more than one occasion. If you look at it, in general, you'll see that it's doing far too much. It is trying to do a whole lot of different things using Twitter and different followers for them and different messages for them. There's too much going on in this single worker. I consider this a code smell. Having a single asynchronous process doing too much is having a God worker. You've probably heard the term God object. This is a God worker. It is doing far more than it needs to. When something breaks, such as here, this is shattered glass. A few people have told me it looks like sugar. When something breaks, you have no idea what just happened. Let's say you got an exception in here somewhere in the middle, maybe somewhere near the end. It would be very difficult to figure out at what stage things went wrong. And had you been doing the data in well-defined small chunks of work, it would be much easier. Pipelining is sequencing or processing a series of stages. And the term, of course, comes from pipelines in which multiple segments are connected together. And it is simply taking that and dividing it into a series of small operations rather than one giant operation. Why should you bother? It's focused. You know exactly what each stage is doing, rather than having to look at this giant blob of work. It's adjustable, and by this I mean in terms of the amount of things performing that step. If you have 10 steps and you discover that your application is bottlenecking on step 3, you can create more workers that are simply processing step 3 jobs. If everything was just one giant job, you cannot do that. In many cases, you won't need this because you won't be bottlenecking somewhere, but if it is happening, it's very handy to have. It's much more testable. It's much, much easier to test one small step there rather than mock out 9 methods to test one. And I encourage you to test what your workers are doing, because having asynchronous workers doing work is not going to be much clearer if you haven't actually thoroughly tested what they are doing. You might have noticed that if you think about the way you're going to be setting things up for multi-stage pipeline processing, each step is going to be receiving the exact parameters it needs to work on, which greatly resembles dependency injection style systems, which are much more testable. And it is traceable. To me, this is the most valuable thing. When something goes wrong, you will know why, or you will at least know where, and that can let you find out why. So here's step 1 broken out into a single process. You get a user, you find the followers for that user, and you enqueue the next step with the new data. It's that simple. This is stage 1 of your data pipeline. Here's step 2. It is the Twitter messages finder. You receive the arguments from the first stage, do the next piece of work, and then you enqueue the subsequent one. It's that simple, and you might be wondering, is it really any better? Like, is this really worth the effort? And it is worth the effort. It is definitely worth splitting things up like this. As I said, all other benefits aside, being able to concisely and accurately find errors is invaluable. Nothing's more frustrating than an error that you can't track down. And to me, that alone makes data pipelining worthwhile. I think the rest of the benefits are excellent as well. Some side notes about this. If you're wondering where to save temporary data between stages, saving it to Redis directly is fine. Passing it as parameters is fine. Writing it elsewhere is fine. If you need to do things based on a time window, do not expect your processes to be run at a certain time. Instead, pass along the specific time window at which you want the processing to be done. Explicitly passing as a parameter is much better than saying, this job should get processed around 6 p.m. today. And when you have a lot of worker types, managing failed jobs can be a little tricky. And I will admit, this is one of the areas where most of the libraries are a little lacking. Look up the documentation for how to handle failed jobs, depending on which library you're using. But this is something that you often have to create some support on your own to work with in your own application. And the last piece of information, or my last piece of advice here, is using a good log aggregator will make this all much, much easier. If you have all of the information for dozens of workers going to a single sequential log file, it can be very difficult to read through. So really, think about getting a good log aggregator. It will save you a lot of time, and it will make getting information about what's happening much, much easier. If you have really specific needs or you don't want to pay for one, making a log aggregator isn't too difficult. But I think if you look at the availability of other options and the pricing of them, it's not prohibitive. Save yourself some headaches. Use a good log aggregator. Start one. Go get an open source one. Pay for one of the services. It's worth it. Let's talk a little bit about logging, but I'm going to go through this pretty quick because we are a little time constrained. Resque has a configurable logger. It defaults to standard out. You can write to the Rails logs. I recommend not doing that because you get a lot more information than you actually need about the state of the worker itself being written there instead of what's processing. You can adjust how verbose it is using the environmental variables verbose and vverbose. Keep in mind that logging can be buffered if you're writing to the file system. And Resque 2.0, which is not ready for production use yet, is still in development, changes the way that is set up. And the logger is only in 1.24 on. If you try and configure resque.logger and it's raising an error because it has no idea what you're talking about, you're on an older version. In that case, just redirect from standard out. Let's talk about the last pattern real quick, periodic maintenance tasks. Resque and friends are usually called primarily from within an application, and there's another convenient use for them, which is taking care of periodic tasks. This is useful when you have anything that needs to be done based on periodicness or on certain times of day or on certain user input. You need to run a data collation job, you need to fetch fresh data from Remote API, you need to write a report about the state of the business, whatever. Simple way to do this, create a worker that will do the work, make a rake task that will enqueue the job, use your scheduler to run the rake task. That's it. If you need a bunch of things enqueued together, there's a slight variation on it. You create the worker, which is the processing job. You make a rake task that will find all the things that need the processing, and then use the scheduler to run it, and it will enqueue all of them. If you need a really large number of things enqueued together, I think you might be trying to do big data, and I'm going to use the scare quotes around that processing using a system not really designed for it. But what you could do, create a worker that will do the work on a single job, create another job that finds the things that need to have this data processed on them, the enqueuing job, make a rake task that will divide things up and find what needs to have the enqueuing jobs enqueued, and use a scheduler to run it. What's a good scheduler? Cron works fine. And if you don't like cron syntax, there's a gem called whenever, which gives you really nice access to things like this. Every 3 hours, every 1 day, every hour, etc. I apologize if I'm going too fast, but we are a little constrained for time because this started a couple minutes late. Friendly reminder, if you're on a cloud host that does not give you access to cron, you can't use whenever. However, they generally offer you some sort of service that is a substitute that you can use to enqueue these jobs. If you need to run something later, but not at a periodic set time, there was something called Resque Scheduler, which was really nice, but it's looking for a new maintainer. If you want to become the new maintainer, people will love you. It's always nice to be loved. If you have an existing project that uses a version that is compatible with it, it does work fine. It's just got some issues now, and going forward, its future is a little uncertain until it finds a new maintainer. And I'm going to skip that. I apologize. So the 3 things we talked about are isolating slow activities, pipeline processing, and periodic maintenance tasks. They all work very well together. Concurrency is hard. Don't feel bad if you get it wrong. Try to keep things in order with shared nothing and idempotent transactions. 4 rules of concurrency. Remember, only do it when you actually will get real benefit from it. Don't do it simply because you want to feel smart. Remember that if you take a consistent and careful approach, it will help you. And is it worth the effort to do this? I say yes, it is. Feel free to disagree if you like. I would love to take questions in the hallway, but I don't think we have time to do it in here, or if you want to tweet them at me. My name is Dave Kapp. I'm at HappyMrDave on Twitter. And I will put up the slides, but I couldn't get Wi-Fi to work, so I will tweet the thing later, and it'll be on my GitHub account. Thank you very much.